We're going to try it and see how today goes. All right. So point signs and planes, we're going to define all of these. And I'm also going to talk to you about how to name them and what they mean in geometry, because they have different meanings, right? Like point, you know, in normal everyday life, right? Like you can point with your finger. That's not what we mean. When we are talking in geometry about a point, we are going to define it as the following: a location in space. So points do not have any dimension. They don't have a width or a length or a height. It's just one tiny little spot. So you could think about the tip of your pen or pencil as a point. So to name a point, the convention is to use just a single capital letter. So if I wanted to show you a point on my paper, for example, we just put a dot to represent there's my point, and then I just name it with whatever capital letter I feel like using. Okay, so why is it a capital letter and not a lowercase? It's just convention. So that's just kind of how, I don't know, whoever set up the system decided let's use capital letters to name points. We do use lowercase letters for other things, so it is kind of important to get in the habit of following the convention. All right, so there is a point. I'll make another point just for funsies. There's a point B. Okay, so that's how we refer to points, just those single capital letters. All right, lines are a little bit more complicated. Lines. So lines are a string of points that continue forever in both directions. So I'm going to draw for you a line, and then we're going to kind of talk about what that some of the parts of it. So when I draw a line, and we have to be very careful with our language in geometry. Lines really have to have these on the ends. So they have to have an arrowhead going in both directions, really, to be considered a line. Okay, if I just draw that, that's something else that we refer to as a line segment, right? It's just part of it. It doesn't go on forever in both directions. So if I want to be specific, and I do here, lines are going to continue forever in both directions. So they are just a one-dimensional, they go on forever. So how do I name a line, right? So what I'm going to do is I'm actually going to, what I want you to do is think about a line as there's like there's an infinite number of points all right next to each other that are all being strung together to create this line, right? An infinite number, just like a number line, right? There's numbers everywhere on a number line. What I'm going to do is I'm just going to pick a few of these random points. Let's call that C, and let's say maybe point D is over here, and then I'll even add a point E. So all I did was I just am highlighting 3 of the points that belong to this line. But there's an infinite number of points, but you know, we would spend the rest of our lifetime trying to name all of them because there's an infinite number, right? So I just picked out 3 random points on this line. So I'm going to use those to name this line. There's actually 2 different ways to name lines. And let's go over the first. Let's call this method 1. So this is the most standard way. This is what you're typically going to see. And the rules for naming lines in method 1, you get to just pick any 2 points. It doesn't matter which 2. It doesn't matter what order you name them in. So you just pick any 2 out of C, D, and E. Just pick any 2 you want. So use any 2 points on the line. And then when you write it, you can write it two different ways. So let's say I want to call this line CD. You could write it just like that. Or we love shortcuts in math because we don't like writing a lot. So your other option is to write a line symbol just like that and then put CD underneath it. So that's another way to indicate which line you're talking about. And order doesn't matter. So you could have also done line DC. It's the same line. You're not going to use 3 points though. So you wouldn't call this line CDE. There's no reason to, right? You only need 2 letters. Don't even bother with the third. Does that make sense so far? Easy enough? Okay. So your second method, method 2, this one uses just a single letter, but it's, this is kind of weird. I'll write it out and then I'll show you what I mean. You're going to use a single cursive. Don't get too hung up on it cursive. Sometimes it's hard to like, I don't know, designate a cursive letter from a non-cursive. But anyway, use a single cursive lowercase letter off to the side of the line. So if I went back up to my little diagram, you might see something like this. A lowercase cursive letter, in this case L. We like to use L for line because we're not that fancy. When we name planes, we call them P usually. I don't know. We don't, not always that creative, but you could call it any letter you want. It could have been line A, B, J, doesn't matter. Okay. Now, one thing that I want to make clear though, L is not a point on this line. You'll notice L, I didn't put a dot up here on the line and attach it to the L. L is just the name of the line, right? So I could now name this line so many different ways. I could call it CD, CE, ED, EC, or I could call it line L. What I can't do is call it line CL, for example, because L is not a point on this line. This is being used to name the line. I hope that kind of makes sense. So, but I can use it to name the whole thing. Let me just shift my notebook here real quick. There we go. So in my example, I can now call this line L. One notation that you're really never going to see, so I'll write it and then I'll put a cross out over it because people don't do this. They don't do the line symbol and then the lowercase L underneath. I don't know why, but that's never really part of the convention. So if you're going to name a line with a single letter, you're going to write out the word line. You're not going to use the symbol. Okay, so that's lines. Now let's talk planes. Any questions so far? Real quick before I keep going. Don't ever hesitate to interrupt me if you're stuck on something. Let me just double check my. All right. Okay, yep. All right, let's keep going. So planes. So this is spelled the same way as the planes in the sky. It is not spelled like planes like the prairies, right? So Planes, planes. So what are these? It's now, so we had a point had no dimension. Then we had lines that go in one dimension, right? Now we're going to have planes that go in two. So they're going to go on forever, not only side to side, but also up and down. So this is a flat surface with no dimension or I'm sorry, with no thickness, that continues forever in 2 dimensions. What? So, it's hard to visualize a plane because we don't really have things in the real world that do this. Okay, we have something that starts off that way. You could think of your desktop. If you're, let's use the floor, even better. The floor is a flat surface of, yes, of course, a floor has thickness, but imagine that we were just talking about the surface of the floor. If you took that floor and it just went on forever, that would represent a plane. If you took the wall that's in front of you, right? If that wall just went forever, that surface would represent a plane. Okay, you could take I have this right here, so you could imagine that this board here, yes, it does have a thickness. It's not a big thickness, but there is one. So you just want to imagine if it had no thickness, but if this just went on forever and ever and ever. If you think about the coordinate plane goes on forever and ever and ever, right? We usually only look at the little region around the origin, but it goes on forever. So if you just imagine this thing that never ends, that's what a plane is. No thickness, it just is a flat surface, goes on. And we don't have anything in the physical world that does that because everything ends, right? So all the floors end. Same thing, we actually don't have anything really that's a line. Someone came up with a good example in the last class of a road, which I agree with, but eventually roads end, right? We don't have any that actually go on forever. So the closest thing I guess you could think of is maybe I would have to come out of both sides. If you had a flashlight that shone light out of both ends, like a lightsaber, and it just kept going, and the light kept going, I guess that could kind of be a line. But hopefully you can visualize it. You can see, okay, yes, a line. I know you know what lines are, but you just got to remember that they never end. So a plane, now we're just talking about it in 2 dimensions. A surface that never ends, just goes on forever. How in the world are we supposed to draw this on a paper? A thing that never ends? Like what? We have a way, don't worry. So this is what we do to represent a plane on paper. We just draw a parallelogram. So that is our shortcut way to represent this flat surface that goes on forever. Sometimes you'll see, like in a textbook maybe, or if someone's being really fancy, they might draw it like this instead. And this is actually a little bit more accurate, I guess. Well, I don't know. It just reminds you that it goes on forever, but it takes 3 times as long to draw. Okay, so most people just kind of stick with this one and understand the notation means like this represents a plane. Okay, so if I wanted to show you things that were on the plane, I can just put them in that parallelogram, right? So I can go ahead and put point A. Let's put a point B over here. I'm going to put a point C over here. And just for funsies, I'm going to add a point D. And then I purposely kind of made it so that these all sort of fall in a row. So I'm going to draw in a line right here. If I wanted to show you a point that was not on this plane, I would just draw it outside of the parallelogram. Okay, so now you see I've drawn 4 points in the plane. I drew a line in the plane, and then I have this one point that's sort of floating away outside of the plane. Now, how do you name these things? Well, there are 2 methods again. So let me go through method 1. And again, method 1 is going to be your more standard way that you usually see it. So I'll do that first. But they're interchangeable. I mean, you can do either one. So the first way is to use any 3 non-collinear points. What? What in the world is a non-collinear point? And I'll add in any order. Would anyone like to take a guess what the word non-collinear means? If you do, just unmute yourself and talk to me. Non-collinear. Anybody? If you're in class, if you just want to shout it out if you know it or want to guess. Anybody? No? You're all still here with me, right? Yeah, I see you. That's okay. I'll tell you what it is. So non-collinear, if you break the word down, non meaning not, right? So I want you to think like coworkers, right? If you have a coworker, that means you work together at the same place, right? So in this case is going to mean the same. And then linear is just a line, right? So non-collinear is just our super fancy geometry way of saying not on the same line. Okay, so let's just verify that this is non-collinear means not on the same line. So naturally, collinear would mean that they are on the same line, right? So actually, maybe I'll just add that as a side note. So collinear would mean that they are, you know what, I'm moving my notebook all sorts of weird ways when I could just move the camera. That's better. Collinear would be that they are on the same line. Okay, so let's put this to the test. What this means, if I'm looking at, oh no, my camera froze. Shoot. Come on, man. Hang on one second. Let me stop the share and then start it again, see if that fixes it. Oh, gosh darn it. Hang on, I just have to reset the camera. Come on, old faithful. Sorry. Give me 1 second. I think I got it now. Yeah. Okay. All right. So I'm trying to name this plane now. So if I'm going to use method 1, I need to pick any 3 points that are not on the same line. So you could not name this plane DBA because they are all on the same line. I'd have to pick any of the 3 points out of the 4 that are not on the same line. So for example, I could name this plane DAC if I wanted. Those are 3 points that are all in the plane and that are not on the same line. You could have also called this plane CBA. Could I call this plane DBE? If I did DBE, that's not this plane because E is not on it. That is the name of a different plane, not the one that's on my paper. So I don't want to use E at all. Okay? Do you guys see why DBA wouldn't work? Can you see that there's another plane that could have all three of those points in it? I'm going to try and show it to you. Imagine that my phone here represented another plane, right? Look at this. See where DBA is? Look, I can take my plane, that's the phone, and put it on that line. Now that line is not only contained in the plane on the paper, but it's also in the plane represented by my phone. So if I started talking about plane DBA, well, which plane are you talking about? Are you talking about my phone or are you talking about the one on the paper? That's why I cannot use 3 points on the same line. They have to be spread out, non-collinear, right? So if I was talking about DAC, D, A, and C, they are not on the same line, right? There is only one plane that contains those 3 points. I can't take my phone and put it over DAC all at once without just recreating the plane that's already drawn. I hope that kind of makes sense. So you just have to use any 3 points that you want. Just make sure they're not on the same line. Okay, and then method 2 is actually pretty short and easy, so I'll just squeeze it in down here. Method 2 is to simply use a single capital uppercase letter in corner. So let me show you what that's going to look like. Let me zoom in a little bit. There we go. Okay. So, oh no, I got to get this lighting figured out. There we go. So what this is going to look like, you're going to have in your plane, you might have a cursive capital letter kind of over in the corner. That's my best attempt at a cursive P. So now I can name this plane P. So one thing that I want to just bring your attention to is that P is not a point in the plane. See how P doesn't have a dot next to it? I'm just using that to name the plane. Just like before with the line, and I had the lowercase letter on the side, that lowercase letter wasn't actually a point on the line. Same thing here. P is not a point in the plane. It's just being used to name that plane. Whew. So far, so good. How are we doing? Everybody feeling all right? We're almost done. I just have 2 more words to define, and then we'll be okay. All right, so if everybody has this, I'm going to go on to my next page. I will post this as soon as as soon as we're done with the notes, I'll post it. So in case you missed anything. Okay, so we got points, lines, planes. The next thing we have to talk about is array. So array is sort of half of a line, I guess, if you want to think about it that way. It has, so let's say it's a portion, yeah, okay, portion of a line with one definite endpoint. And, oh, don't tell me my camera froze again. What is up with this thing? Hello? Jeez Louise. Sorry, guys. Give me one sec. I don't know if there's just a way for me to like refresh it. Let's try this. Yeah, it's just stuck. Yeah, it's telling me to restart it. Yeah, okay, thank you. Sorry. Old Faithful's giving up on me here. All right, we're back in business. And you can see my screen already? Yeah, okay, cool. All right, my dear. Come on, camera. Let's go. Portion of a line with one definite endpoint and that continues forever in one direction. So array is going to look like this. We have that one endpoint, and then one side's going to keep going forever. The naming convention for array, this is the first time that it's really particular. And for all the other ones, the order doesn't really matter. It matters a lot for array. So let me just highlight some of the points. The endpoint's going to have a name. So I don't know, let's call it X. Let's say we have point Y here, and then somewhere else we have point Z. Okay, so here's an image of array. To name it, I have to use the endpoint first. That's the sticking point. To name.
Thank you.
But then once you name the endpoint, then you get to use any other point on your array. Then it doesn't matter. Okay, so if I wanted to name the ray in my diagram here, I'd have to call it ray X. It has to start with an X because that's my endpoint, but then I get to choose if I want to use either Y or Z. Another way that you can write this notation, just like we had a symbol for line, there's a symbol for ray. You just do a one-sided arrow like that. So you could have called it ray XY, written it out, or just use the symbol. Or you can do ray XZ or XZ. But what you cannot do, those are really your only options. So you either had to go with XY or XZ. I'm going to write it and then cross it out because this is incorrect. You could not do ray ZX, for example. That is not an option because that does not start with the endpoint. Okay, so that's ray. And then we only have one thing left and then we are done. Any questions so far? Feel free to, I mean, don't feel like you, absolutely feel free to interrupt me if you have a question. Okay, the last thing we need to do is talk about a line segment, and that's nice and short. And its definition is simply a portion of a line with 2 definite endpoints. So these do not go on forever and ever and ever. This has definite endpoints. Let's just call them, oh, I don't know, L and M. So if I want to name this line segment, it's just as easy as using the endpoints. Order doesn't matter. I can call it line LM or ML, does not matter. So, but you're going to refer to it as segment LM, or luckily for us, there is a symbol for this also. It's just a bar. You would not use arrowheads. It's just the bar, okay? So you could also swap it around and do ML. So the only one where order matters a lot so far is a ray. For a line segment, a plane, a line, order doesn't matter. You get to choose whatever you want. The only other one that has one thing that you got to remember is the plane. You just can't pick 3 letters that are on the same line. So they have to be non-collinear points is our fancy term for that. Okay, so that's it for the notes. You do have a homework for the weekend, but it looks like we have a chunk of time. You might be able to get it finished here. So I'm just going to write, just so it's part of the notes. Homework is going to be on Delta Math 1-2 points, lines, and planes. Lines, planes. Okay, so I'm going to go make that live for you right now. So you can go ahead and get started. This might be our first Delta Math assignment, isn't it? I don't think we've had one yet.
Nope.
Ooh, okay, let's see how this goes. So give me 1 second to just make it live. Oh, for the love of math. There are so many tabs. I can't find what's what. Oh, you know what? I'm going to stop the share. And I'm also going to stop the recording if I could figure out how.